Hello, Jesse.
Hello, hello, hello.
How are you doing?
Great. How have you been?
Very well. Fit, focused, goal directed, goal oriented.
Good. So,
Bit maybe perhaps more perfectionist than eager for progress.
okay, tell me about it.
Um, yeah, I guess where that is coming from is that progress seems to be a little slower than I'd hoped. And why does progress seem to be slower? Well, it's because we are wrapping together loose threads that were up until now developed and built independently. And when you try to tie them together, it shows up that the interface doesn't quite align, and you have to do a lot of translation of interfaces, and that's
So, offline we talked about
laborious.
talking about the roadmap. So maybe let's bring in some context for the listeners. What kind of loose ends are you talking about?
For instance, last week or the week before, I was working on time locks, which is technically speaking a smart contract, and it prevents a UTXO from being spent before a set release date. It's an incredibly useful
And
feature.
for our listeners, UTXO is what?
It's the digital equivalent of a coin. It's the thing that is being traded in a transaction.
And it stands for what?
Unspent transaction output, but it the acronym is used to denote things that are not implied by what the acronym abbreviates. So it's
What does that mean?
better to think of it as a standalone thing, and it also happens to be the output of a transaction, and in fact, it's also the input of a transaction.
But there's also somewhat of a design choice here because not all blockchains operate on them, right? I believe Bitcoin does, but maybe elaborate on that just a little bit.
Yeah, Ethereum uses a different model for what is it? Storing the database of who has how many coins. They have accounts. So every public key is associated with an account, a certain balance in Ethereum, and in fact, any ERC20 token has a balance associated with your public key. And then a transaction is just a bunch of updates between accounts.
And
And you can think of the UTXO model as creating a new account whenever it's possible.
and
So
so
accounts
why
are
are
really, go ahead.
why do these different philosophies exist? What are the trade-offs?
Um, the UTXO model is slightly more amenable to privacy because if you make two transactions, it's not obvious that they are linked to the same person because you get two different UTXOs. Whereas in the account model, both of those transactions point to the same account, and so
But
definitely
if you
are
were
linking them to
to
the same person.
create a new account in the account model for every transaction, would it be equivalent to the UTXO model?
Yes, it would be, but it would give the uh, wallet software a more challenging engineering task to keep track of all your accounts. And moreover, it would be difficult to interact with smart contracts because the way things work is you have to pay upfront gas in order to convince the miners to run your smart contract. And there's a bidding that happens, and the miner who wins that bidding process gets to pocket the gas, and whatever is left goes back to the person who initiated the smart contract. And so, if you want to do that in a UTXO model, you have to create a return UTXO that might end up not being used. It's possible, and architectures have done this, but I think it's more straightforward to do gas in an account-based system.
Okay, I think that's enough of a detour. So you were talking about UTXOs.
Yes, and they can be time locked since 2 weeks, and this is
What does that
important
mean?
for. Sorry.
What does that mean?
Well, that means that this coin, this UTXO, cannot be spent before the release date that is now encoded together with the coin itself.
Hmm.
And you might need this for Lightning. You might need this for cross-chain atomic swaps, and we're definitely going to need it because the pre-mine will be locked up for 6 months until after
And
launch.
isn't this one of the very basic features that the Bitcoin script also supports?
Yes, Bitcoin supports this.
Okay, so you were working that has not yet been implemented. You were working on that these past 2 weeks.
Yes, it's there now, and we were talking about the difficulty of tying loose ends together. Um, and so I wrote unit tests to make sure that recipients of pre-mine tokens cannot spend them before the release date and can spend them afterwards. And it turns out that once this time dependency becomes a condition for transaction validity, then a whole bunch of transactions are suddenly invalid because their timestamp is whenever you run that unit test. And the timestamp of the release date is 6 months after mainnet launch. And so you have to find a way to generate transactions that can be spent, uh, generate a transaction with a tweaked timestamp as though they have only been generated 6 months after launch.
But
Now, that's obviously possible, but it's a little more engineering work than you might expect upfront.
this is just a like higher level engineering of unit tests, though, right?
Yes, you can describe it as such. It's
And so for the complete non-technical, a unit test is the most basic test that you write as a software engineer to test a single function.
yes, and in fact, most of our, well, maybe not most, but plenty of our tests are actually integration tests rather than unit tests. And so integration tests are where you start tying together multiple different software components to make sure that they interact in the correct way. And those are trickier in regards to tying together loose ends.
Okay, so maybe zoom out a bit now and take us walk us through the bigger picture of your roadmap, where you're at, and what's still to come.
In regards to the Neptune Core client, which is the software that's going to run a node on the Neptune network. What's left to write in big picture terms is the consensus logic for transactions and for blocks. So this is essentially the logic that says when a transaction is valid and when it's not valid, or when a block is valid and when it's not valid. And the reason why we've been putting this off until the very last is because it relies on recursive Starks.
But let me pause you for 1 second, because if you're building a blockchain and you say you've put off the consensus part to the end, to a layman as myself, that sounds like quite a major part. So how does that fit into what are the other major parts that are finished?
The privacy architecture. So you can already send and receive Neptune tokens using the mutator sets in a way that is both scalable and private.
Hmm.
The
But you
networking
can,
client, you can discover peers and connect to them and bootstrap your list of known peers. You can distribute blocks, you can distribute transactions, you can mine.
So if
Um,
you were to release this into the wild, you would be able to build blockchains. You would just not be able to agree on what is the mother chain. You would not converge.
right now, actually, we will converge, but that's because the current placeholder logic um, is well defined, and everybody who's running the current testnet will actually converge on the testnet chain. The point is that this placeholder logic is not feature complete.
So that's like a very rudimentary placeholder for the consensus mechanism.
Correct.
Okay, and is the
Not
consensus
the consensus mechanism, right? Consensus logic.
okay?
So
What's the difference?
it's the logic is whether a transaction or a block is valid or not. It is consensus critical because if two nodes disagree about this logic, they will hold two different forks of the chain as canonical, and they will end up disagreeing and therefore break consensus. The consensus mechanism is proof of work or proof of stake. In our case, it's proof of work that uh, generates the longest chain according to which the longest chain rule decides which view of history is canonical.
So what goes into the consensus logic? How does it determine if it's a valid transaction?
Well, the transaction kernel goes in. Transaction kernel is a list of inputs, list of outputs, list of public announcements, timestamp, uh, optional Coinbase amount, a fee, and I think that's it. Um, and it's valid if all the lock scripts halt, which is to say every input UTXO comes from, excuse me, every input to the transaction is a cryptographic commitment to a UTXO. That UTXO determines a lock script, which is how the owner of the UTXO approves of an expenditure. And so in order to approve of an expenditure, you supply the inputs to the lock script such that the lock script halts gracefully. And so one condition for the transaction to be valid is that all the inputs have lock scripts that halt gracefully. UTXOs have more scripts attached than just lock scripts. They can also have type scripts attached, and they determine how state evolves. And in the case of money, state is just amounts, and you want amounts to never be negative. You want, moreover, the sum of input amounts to be equal to the sum of output amounts. And this logic is encapsulated in the TypeScript of money like UTXOs. Um, and moreover, you want to ensure that the cryptographic commitments to UTXOs that are the inputs and outputs are actually formatted correctly. Um, they're not bogus commitments, but they actually represent
But
a UTXO
why?
that exists.
Because why does this? Why do you refer to this as consensus logic? Because to me, it sounds like it's all like transaction logic.
It is absolutely transaction logic. The point is that transaction logic is consensus critical because if you and I disagree about transaction logic, we cannot reach consensus.
Gotcha. Okay, so it sounds like some of this is going above my head, but it sounds like there's you're sending out a transaction that transaction supports different types of scripts. Um, s- some might be required, others not, and this consensus logic basically checks all those things.
The consensus logic for transactions checks all those things. Yes.
Okay, and what's
There's
what's
also consensus logic for blocks.
Okay. Is that worth discussing as well?
Yes, but we're first going to solve consensus logic for transactions, and consensus logic for blocks is going to come later. So I have less of an overview there. But I'm happy to ask questions if you can ask directed questions.
And why do you need blocks again? Why can't you just do it at the transaction level?
Because you don't want users to have to engage in proof of work in order to have a good chance of their broadcasted transaction to be confirmed.
Because proof of work is done at the block level.
Proof of work is done at the block level. Yes.
Okay. All right.
So it's initiating a what is it? A separation or a division of work. We can expect miners to do work, but we don't expect users to do work. So it should be cheap for users, but miners can carry a heavier load. And in Neptune, we're actually driving this to the next level where we expect miners to do all the heavy working related to proving stuff, and users can get away with relatively simple cryptographic operations.
hmm Okay. So, how far along are you with the consensus logic?
So right now we have the proof of correct index derivation, which is related to the mutator set. And this is the reason why we can already send and receive private transactions in a way that's both scalable and private. We also have time locks since 2 weeks ago and amounts. But what's missing is,
So
go
hang
ahead.
on. Because you're saying you can already send private transactions, correct? That's what you said,
Yes,
right?
yes.
So, how does that look like? Like you want to send something to your co-founder Torquil. How does that look like?
From the user experience,
Yeah,
or what is
let's let's
confirmed
let's let's
on the
start
blockchain?
there, but then let's also talk about what appears on chain.
All right, I will need his public receiving address, which is, I guess, 1,000 bytes or something, maybe 2,000 bytes of cryptographic data. So you won't be able to see any patterns in there, except after it's been cast into Bech 32 format, which
So
is
so
a error correcting code.
so this will be like a massive QR code, or how should this how do you
It
envision
will
this?
be a massive QR code, or you can send it in an email, or put it on a thumb drive or something. It's rather difficult to copy digit by digit, but
Okay.
as long as there's a digital way to copy it, it's fine.
So he's published this, and you need to know what it is.
Yes.
Okay.
And then I open up the user interface and press send, put in his
Well, and sorry,
address, put
the
in an
user
amount
interface of what?
of Neptune.
Of the Neptune client.
Yes. So the Neptune client is a daemon that runs in the background on your machine. And when you want to send or receive, then you open up an application that is user facing, and that's the interface.
Okay, and that shows UTXOs that belong to you, and then or how?
It actually sums the amounts in all UTXOs. So, uh, as a user interfacing with the interface, you don't have a notion of UTXOs, actually, just aggregate amounts.
It shows you
But
an amount.
yes, it shows you an amount. And it also shows you your own address, and it gives you the option to send coins to another address.
Okay, but how's this private? Because you've got a bunch of addresses with coins in them. He's got an address, and you're about to send um, the coins on let's say one of your addresses to his address. That's going to show up on his address. How is this private?
The point is that the data that is published on the blockchain does not tie our addresses together.
Okay, and so the balance can also not be read.
The balance cannot be read unless you're Torquil or you're Alan.
So
No one
what
else can see the amount that's being transferred. They can see that a transaction took place between users, but they
they
don't
cannot
even
even
know the
see,
type of currency that was transferred.
and not even the addresses.
So it depends on which type of address you use. And right now, we only have one type of address called generation address. And there is some weak linkability here because the idea is you write this down for the next generation, for your kids, and you donate over the course of your life at locations, whatever you can, at several points in time over the course of your life, you donate to this single address whatever you can, and then your kids, when they become of age, they can open up this generation address and collect all the donations that have come in the meantime. And the trade-off for having this, what is it? It's a paper wallet that is enough to recover all the amounts that were sent to this same spending key. The trade-off here is that all the donations to the same spending key can be linked together. Down the line, we will support other addresses where this trade-off is different, and so you won't be able to use that for a paper wallet, but you will be able to destroy even this link between donations
And so why did you start with that?
because it's the most basic use case of say sending money to your future self. You write something down on a piece of paper, and that piece of paper is all you will ever need to recover your funds, as opposed to having to make backups on your computer and making sure you don't lose those backups.
Okay, so the address we were talking about here by your co-founder Torquil, that would be a generational address for Torquil. That's donations for his children, let's say. So then inspecting what's on the blockchain, one would be able to see, hey, these are all going to the same address, or what?
Yes,
Okay, but that's a link that's easily severed as well in the future.
with future address types, yes.
Okay, but so the amount is unknown, and also the origin um, UTXO is unknown.
Correct.
So, but are you just only implicating your co-founder then?
What do you mean by that?
Well, if let's say someone's observing the blockchain and is looking for, okay, who's using this completely private financial infrastructure, and then everything's accumulating in one account. That's how it would sort of look like, right?
I guess, but it's also worth noting that there are no identities on the blockchain. And so things are accumulating into one account, but you don't know how much and you
Hmm.
don't know who it belongs to. So you really only know how often there was an accumulation and you don't know anything else.
Right, and so compare that to now. Like sometimes we see news. Like on Twitter, for instance, I saw recently some posts about somebody they call Mister 100, because there's somebody that's been, or that there's a Bitcoin address that's been accumulating 100 Bitcoin every week or something like that on a regular schedule. That type of information would not be knowable. You would just have some transaction occurred involving this address, or like where this address has been the receiver, and that's it.
And that's it. And you don't even know, contrary to Bitcoin, you don't even know if the money has been spent in the meantime.
Okay, whoa. And that's the basic version, because in the future you won't even that destination address will not be known. Okay, yeah,
Correct.
it's quite different from what we're used to. So I notice it takes some time to wrap your head around what that what that world's going to look like, because it is a bit strange. And so maybe we can talk about that for a second. How do you view that world?
I think it's the natural extension of human will acting on the economy, which is becoming more and more digital. Um, and so, just as we used to have messengers that were not encrypted, and now we're transitioning to messengers that are encrypted, so too is money transitioning from a prototype that is not encrypted, if you will. I don't think there's an encryption per se, but it's
So
some kind of obfuscation, and now that obfuscation is there too at long last.
have you ever heard Lawrence Lessig talk about the sort of the internet pioneers, and how and his critique of them? You know, there's an interview that he did. You know Lawrence Lessig, right?
I've heard of the name, but I can't attach it to something that
He's,
I would read.
I mean, I'm gonna botch his biography, but he's basically he's like an MIT professor in law, and I think he's one of the things that got him famous in computer science circles is that he wrote a book where I think he posits that there were always two ways to structure human behavior. One was through architecture and just like physically. The second was law, and then with the advent of programming, computer code became a third one. That's sort of the framing that he gave it. But the critique that he made on I forget who the guys were, but there's like this declaration of independent cyberspace or something at the beginning days of the internet, and there's a couple of guys, they declare, like I don't know, corporate interests or governments, you're not welcome here. This is a free for all,
You
and
have no sovereignty here.
you have no sovereignty here, exactly. And that did not pan out. The internet was shaped differently, and I think his point was like that was inevitable, because there's always this this interaction between law and technology, no matter what. Um, so what do you say to that?
Um, I think it's an interesting point of view that I learn like to learn more about, and cultivate a more profound opinion. But I can tell you where my first knee jerk reaction is going, and I think law is capable of interfering in interfering, regulating, depending on your perspective, um, domains of human action um, that are less powerful than law. But there are things that are more powerful than law. Um, and another example of something that is more powerful than law is war. There is no law, there is no international law, and to the extent that there is, nation states routinely flaunt it, flaunt.
Flaunt, yeah.
Um, and that's because in when faced against an army, law has no teeth. Um, Law does have teeth when it comes to regulating what's being published within a geographical area on the internet even. Um, but where law doesn't have any teeth again is um, maybe that sentence I just started isn't quite true. I see this as a battle between the economy yearning to be free and aspects of the legal system yearning to suppress that freedom. And between the economy and the law, I think there's a dependency relation because in the end, the political system it has income too. Its resources come from the economy, and so it cannot be too inimical towards the economy. It has to allow the economy to flourish in order to sustain its own life. And so, as cryptocurrency's relentless march continues forwards, it will garner more and more political support from because the state is not one monolithic entity. It's a whole bunch of forces pulling in different directions. And as cryptocurrency becomes more popular, some of those forces stand to lose, and some of those forces stand to benefit. Um, and so the economy will march relentlessly towards adopting cryptocurrencies, and the legal system it will have to comply. It cannot require compliance, as I see it.
Well, the legal system will have to give way because it's just such an inevitable push, is what you're saying.
Yes, and those jurisdictions where the legal system does not give way to the ascent of cryptocurrency, they will make themselves irrelevant because the new businesses and the profits they go elsewhere.
But let's go into this a bit deeper because I'm fascinated by some of the like sociological implications of this because for instance we both live in Switzerland and we are taxed with something that's called Quellensteuer, which means the tax at the source, and that only works if the government knows exactly how much you earn. And it's I have to say it's quite convenient because I don't need to do my taxes. The government does the taxes for me. But all of that kind of stuff is out of the window. It's that if there's still a government that wants tax revenue, they need to trust the citizenry 100% that they will comply.
I I don't think there's demand for anarchy. Actually, there are plenty of notable anarchists, but by and large, most people want to have a government. And I think in order for the state to get resources, they have to tax smarter. For instance, as a company owner, I'm afraid that investors who I might disappoint at some point will go after my personal savings. And they're not supposed to do that because it's a limited liability company. And I want the government's protection of my personal savings in the event that, unfortunately, I make my investors unhappy. In order to earn the government's protection, I need to make sure that my books check out and that I paid my taxes. And so I think gathering resources from the state's point of view will happen mostly via companies, and I think taxation at source makes a lot of sense, um, because the assuming that the company's books are open, or at least transparent for the government, and they check out, then they'll make sure that those foreigners that they employ have been taxed.
Yeah, back to Lessig's point, I think his point can be described as that there's always a balance that needs to be struck between law and technology, and I think that's kind of what you're saying now as well, is that the balance might shift, but there's no appetite for complete anarchy, so it might they might need to innovate, so that might get interesting.
Exactly. Yeah, maybe I'm not entirely opposite to Lessig after all,
No,
by how you summarized the situation.
he's I think he has a very reasonable viewpoint. Okay, I think that that might be enough for this week. What do you think?
That sounds like a round point to close things on. Can you help me find a good title for this video?
Yeah, we can do that offline.
All right, let's do it offline.